Today we shall learn about adaptive support ventilation. This adaptive support ventilation it was first developed by Hamilton Medical and it is available only on Hamilton Medical Company ventilators. It is an intelligent ventilation mode and it is also a dual control mode. Dual control mode means it automatically adjusts the pressure and volume such that for a given least pressure the tidal volume is reached, and it also provides a mandatory minute ventilation. Mandatory minute ventilation here means whenever the spontaneous ventilation of the patient is less, then the ventilator gives more support such that the minimum mandatory minute volume is reached. And when the patient's spontaneous effort is more and the minute ventilation is high, then there will be no or minimal support by the ventilator. So this is called as minimum mandatory minute ventilation. And the clinicians have described this adaptive support ventilation as one mode from intubation to extubation. So what does this mean? That is one mode from intubation to extubation. Conventionally, what happens is initially we keep the patient on assist control mode. That is whenever the patient is paralyzed or heavily sedated, we keep the patient initially on assist control mode. Then we change the patient to SIMV with pressure support. From there we change the patient to pressure support ventilation, then spontaneous breathing trial and extubation of the patient. But in case of adaptive support ventilation, we need not do all this change of mode every time. So once you keep the patient on adaptive support ventilation till the extubation, only this mode is sufficient. We need not change the settings of the ventilator every time. So this is the beauty of this adaptive support ventilation mode. And it is also called as a 3-in-1 mode. 3-in-1 mode means it indicates that is whenever the patient is inactive or patient is passive, this adaptive support ventilation it acts like a volume targeted pressure controlled mode. And when the patient is active or spontaneously breathing and the respiratory rate is less, then it will be like a SIMV mode. And when the patient is breathing spontaneously and patient's respiratory rate is adequate, then it will act like a pressure support mode. So that is why it is called as 3-in-1 mode. And it is also a closed loop ventilation mode. Closed loop ventilation mode means it uses a feedback signal to adjust the output of the system. Here what is the feedback? Here the feedback is the minute ventilation. Whenever the minute ventilation is less, then it takes that one as the feedback and it automatically increases the output such that the given minute ventilation is reached in the patient. So this is called as closed loop ventilation. So now we shall see what are the settings we keep in a patient with conventional ventilation. In a conventional ventilation, we have to choose either it is continuous mandatory ventilation or SIMV or spontaneous mode. Then we have to choose the pressure control and this pressure support, inspiratory time, tidal volume and respiratory rate, inspiratory pause, IE ratio and PEEP and also FiO2. All these parameters we have to set in a patient who is undergoing conventional ventilation. In case of adaptive support ventilation, these are all the major parameters which we set. That is minute ventilation. How much minute ventilation we need to give to the patient. We shall get to in later in this slide. That is how this minute ventilation is calculated. That is 100% minute ventilation we want to give to the patient. Then what is the PEEP and what is the FiO2? And also we have to enter in the parameters, that is the height of the patient. What is the height of the patient? Sex of the patient and minute ventilation, then PEEP, FiO2. So here based upon the height and the gender of the patient, the ideal body weight is calculated and the minute ventilation is calculated as 100 ml per kg of ideal body weight. For example, the ideal body weight is 60 kgs, then the minute ventilation will be 60 into 100, that is equal to 6000 ml or 6 liters will be the minute ventilation. And these are the other parameters which we set in case of adaptive support ventilation, that is pressure ramp, or this is also called as slope. It is usually kept at around 100 milliseconds and 50 to 100 milliseconds, and this is the inspiratory trigger 1 to 2 liters per minute we keep. And this is expiratory cycling. When does this cycling occurs? When the flow rate it reduces to 25% of the peak flow, then cycling occurs. And also maximum pressure limit is kept at around 30 centimeters of water. So these are all the parameters which we keep in case of adaptive support ventilation. We are not going to set the tidal volume, and we are not going to set the respiratory rate. Now we shall see how the ventilator adjusts the tidal volume and respiratory rate in order to achieve the minute ventilation in a given patient. So this is the graph in patient with adaptive support ventilation. On the x-axis we have got the respiratory rate, and on the y-axis we have got the tidal volume. See this green point, whatever we are seeing, this green point, this is the target value in a patient. That means the target, that is 16 respiratory rate and 434 ml. This is the ideal target for this patient, such that the work of breathing is minimal in this patient. But in this patient, what is happening? This plus mark, this indicates the tidal volume and the respiratory rate. It is operating at this point. So the ventilator, it automatically adjusts and it continuously adjusts the settings and the output such that the patient reaches the target point. So this is the what the beauty of the adaptive support ventilation is. And how is this respiratory rate calculated? Respiratory rate is calculated by the Otis equation. So in this Otis equation, this is the Otis equation. F is, that is the respiratory rate, is equal to 1 plus 2 alpha. Alpha is the constant for sine flow, and RC is the airway resistance into minute volume minus F into, this is the VD is the dead space divided by dead space minus 1 whole divided by alpha into airway resistance. So based upon this Otis equation, the ventilator, it calculates the optimal frequency such that the work of breathing is minimal in the given patient and the patient comfort is maximum. So this adaptive support ventilation, it provides volume target pressure control breaths in a patient who is passive, that is patient who is paralyzed or patient who is sedated, and it acts like a pressure support mode in patients who are actively breathing. And here in this graph, in this is the interface. This is the interface of the ventilator. We can see all these are the floating indicators. We can see this is the dark blue, this is the dark blue color, and this is the light blue color. So whenever these floating indicators, they come within this light blue, then it indicates that patient can be considered for a spontaneous breathing trial. So this indicates, that is, whenever the FiO2 is less than 40 and your PEEP is less than 8 centimeters of water, minute ventilation is less than 10 liters, and that is between 10 liters to 3.5 or 3.6 liters, and whenever the inspiratory pressure is less than 10 and rapid shallow breathing index is less than 100, and the spontaneous breathing, contribution of spontaneous breathing is 75 to 100%, then it indicates that patient can be considered for a spontaneous breathing trial. So now what are the advantages of this adaptive support ventilation? The advantages of adaptive support ventilation are enhanced patient comfort and also lung protective ventilation. So it avoids abnormal increased pressure and also prevents the barotrauma, and the ventilation time is decreased, and reduction in treatment costs, and the intensivist can concentrate on many other things of the patient management like hemodynamic management and invasive procedures and pharmacotherapy for the patient in the intensive care unit, and also less time is required for training of medical and also paramedical staff. So these are all the advantages of adaptive support ventilation. Thank you.